In this talk, I will present to you one of my most recent robotic installations called Xenoforms, a work that integrates the areas of robotics, artificial intelligence, synthetic biotechnology, and architecture. The purpose of this work is to comment on machine agency and the computational colonization of the physical space. With the integration of artificial intelligence as an omnipresent artifact that permeates every aspect of human existence, the work provides a case in which a robotic agent, as a laboratory researcher, attempts to identify the conditions in which the boundaries of technological infrastructure expand beyond the present norms and to integrate within the physical matter of our surrounding tangible world. Under this supposition, it is important to both speculate and consider how synthetic matter that integrates sensing, actuating, and communicating abilities with machine intelligence reforms our surrounding spaces, architectures, and cities, and to further discuss how the symbiotic relationships between organic and inorganic agents are being disrupted and reframed. Practices of biological sciences have demonstrated that the creation of synthetic life can be made within a laboratory. In 2010, a research team led by Craig Venter created the first self-replicating synthetic bacterial cell that was chemically synthesized in the laboratory and was successfully transplanted into a recipient cell that produced a new self-replicating cell controlled only by a synthetic genome. A wide range of practices within this discipline has demonstrated the development of artificial organic systems for environmental remediation, the manipulation and modification of genome sequencing, or the integration of engineering and nanotechnology with biological matter. Pavel Gotovtsev also suggests methods of moving the Internet of Things closer to synthetic biotechnology and allowing cells via genetic logic circuitry to perform networking between other cells and computational systems. Applications of this Internet of Nanothings are being investigated in healthcare and agriculture, as well as for intelligent infrastructures for architecture and the city. This work builds upon this hypothesis that synthetic organisms will manage to self-replicate, expand, and autonomously shape their form and function, while simultaneously remaining connected with larger frameworks and systems. To my understanding, this process is not too dissimilar to the colonization practices of biological parasites. According to this, my methodology was to develop a series of prototypes that resemble the form and behavior of parasitic organisms. A machine learning model was trained using data collected from parasitic and colonial organisms, especially Xenoforms, a hydrozoite of the Cnidaria family. Through this process, a series of diagrams and images were generated to assist in the design of three-dimensional models. Following this, the models were 3D printed using stereolithography with specialized resin materials, resulting in high-precision physical representations of the synthetic forms. The work features a robotic system that has been trained to act as a self-motivating and autonomous machine that continuously examines the properties of the generated prototypes. Here, we view a system that pursues to create its own meaning and construct artifacts and processes that reflect its own self. This reinforcing behavior to realize the set goals demonstrates not only a strong survival and evolutionary drive, but also a narcissistic and egocentric attitude. The agent has to measure, define, and control every function and matter of the surrounding environment. Regarding the technical facilitation of the Xenoforms, I utilized a 7-axis robotic arm that incorporates 4 sensitive features. Custom-made grippers were fabricated to accommodate better interaction with the 3D printed models, and further software implementations were made in C++ and Python to ensure consistent behavior and a wide range of control for the robot's physical responses. Here you may see the full system architecture and the processes followed for generating this work. The system has been programmed to communicate via Modbus with external systems via Python Node.js sockets so that a larger array of media interactions can be accommodated. To further enhance the immersive experience, the work includes real-time visualizations and sonifications that are used to convey behavioral and cognitive information about the robotic agent. Real-time processing queries are forwarded to a dual deep state translator that is tasked to generate visual and sonic representations. As the original data generated and processed are complex and multidimensional, the translator ensures that the content is put into an understandable form so that the audience can empathize with the experiences of the robotic system. The final installation consists of a range of printed posters, 56 selected 3D printed forms, the robotic system, LCD screens that display the visualizations, and an audio system used for the sonification. This commissioned work was exhibited in November 2022 in Shanghai. Here we will review the installation video. Xenoforms highlights the anticipated moment when computational systems define self-established goals and motivations, and ask us to consider the symbiotic conditions that are expected to be formed between physical objects, biological organisms, synthetic biotechnologies, and artificially intelligent entities. The installation raises questions on the implications of computational colonization and the potential consequences of advanced artificial intelligence and autonomous systems in shaping, monitoring, and controlling the architectural spaces we occupy. Xeno, coming from the Greek word xeno, translates to foreign, alien. However, in this instance, it does not refer to technological advancements that are hostile and threatening, but it is rather used to create a case that reflects on the sense of the unknown regarding AI systems, especially those within the artificial general intelligence spectrum. In a similar way that parasitic and colonial organisms take over the host and/or its environments, without their full understanding or control. Autonomous computational units will be seen to intrude multiple and diverse layers of our physical, digital, and hybrid spaces. This explorative work can be seen as a pursuit of novel cosmotechnical pluralities in an attempt to better shape an understanding regarding humanity, technology, and the built environment. Through this perspective, we are invited to consider the ethical and societal implications that this technology brings and reflect on the protocols of governance and regulation. Coexisting with autonomous systems will create a new era that will reshape our built environment and us. Thank you all for listening.